So my name is Karen Davis. I'm a principal technologist or principal data engineer. I started my career many years ago as a software engineer and then moved over into the data space. So I'm always looking for ways to apply software engineering best practices to data. I'm an advocate for things like trunk-based development and continuous delivery and continuous deployment when building data pipelines. But my talk today isn't about those. So what are we going to cover? Obviously, data replication patterns, because that's the name of the talk. But we're going to also look at some other elements that can influence how we make technology decisions when choosing data replication patterns. So things like how the data will be used, what the core time projection is, coupling in data engineering, obviously choosing a data replication pattern, and we'll look at 3, and then what idempotency requirements we may have as well. What we're not going to cover is things like data security, data governance, path to production, data quality, versioning, all really, really useful topics to be looking at when choosing a replication pattern, but just didn't have enough time to put them all into this talk. And speaking of time permitting, at the very end, because data mesh is such a hot topic, we will talk a little bit about what it means to shift from data replication patterns and data pipelines into data products, time permitting. So let's get started. Because what we are talking about can be quite abstract, I thought it would be really useful to have an example that we can use. So the example we're going to use is RealCo, and they, despite the name, they're not a real company. I just want to make that really clear. They're an online sporting goods store. And they've built the website. The website has been running for quite a while. But what they really want to be able to do is show some real-time, personalized purchase analytics as a tongue twister, to customers. And we might have a scenario here where it's actually team A who look after the website, and then we have a different team who are looking to build this analytical feature. What we're going to use throughout the talk as well is this kind of scorecard. And we're going to capture kind of all of the choices that we make, and then we'll use it at the end to kind of inform what technology choices we might make. So you can see from here, for RealCo, for this particular use case, we need about 2 months' worth of data. The data is available to us via an API. Team A make that available. And RealCo are really starting out on their journey. So they don't have a lot of data platform infrastructure. They're just really kind of starting out. Is that all clear? Great. We can jump right in. So the first thing we want to really understand is how the data will be used. This is really important. It's generally the first step I take when kind of understanding it, and we'll get into the reasons of why. But generally in an organization, there's 3 main ways that data can get used. So you've got your operational use case, your traditional OLTP, and this users here have particular expectations. So they expect, millisecond response time, and they're generally accessing data row by row or very small data sets altogether. We've then got the analytical use case, which is our traditional OLAP, and this is where we have a user who is maybe accessing a larger data set. They want to do some processing here. Latency requirements here are a little bit different, so people kind of generally minutes, hours, seconds, minutes, hours are all okay here. And yeah, as I said, we're kind of crunching that larger data set for usage pattern. The types of things we might have here are things like operational reporting, dashboarding, training ML models. And then we've got kind of hybrid use cases, which is it's a little bit newer, and it's like mixing kind of the requirements from the operational use cases and the analytical use cases as well. So this is where you have you have a single user, and they have like expectations that the data is going to be delivered really, really quickly. So they might be accessing like an analytical feature as part of a website. It's really kind of important to understand where your use case fits in, because I've kind of talked about like different infrastructure requirements that you may have. Yeah, and generally data flows from operational use cases into analytical use cases or into the hybrid use cases as well. But we're also seeing cases where analytical data needs to flow out into kind of operational systems as well. So it's getting complex, and it's getting a little bit more complex as well. And generally for the talk here, we're going to be focusing just kind of on the initial moving data from source systems and moving it into analytical or hybrid use cases. Why is it important that we understand that? I sometimes see scenarios where it's almost like a data pipeline can be doomed before it's even started. So we're trying to do things that the general infrastructure doesn't support. So we might be trying to build a search feature, and we might be trying to do that in a normalized relational model in a data store, when really we should be moving it out somewhere else, denormalizing and doing some stuff for it. Or another example might be trying to serve analytical data from your data warehouse, where the latency, like serve it to web users from your data warehouse, where the latency expectations don't match. So for our RealCo, we can see that the use case is hybrid. So we have those kind of real-time expectations around the data, but we're also going to be doing a little bit of analytical processing. We're lucky in that it's not too much analytical processing. It's going to be about 2 months worth of data. We have expectations for real-time freshness. We have expectations around millisecond response time. And the enterprise context, again, is data is available by an API, and we're just starting out on that journey. So that's understanding the use case. The next thing we want to do is we want to understand the core time projection. What do I mean by this? I've sometimes heard this called CDC, change data capture pattern, in a traditional data warehouse, but we want to understand how we have to capture the data. And there's two main ways, and I will talk about them. The first way is like a current state to current state. So in our source system, for this example, we have a car, it is blue. And in our destination system, we just want to replicate that current state. We don't care about historical changes that have happened over time. So that's one of them. The second one, I'll give 2 examples of how this shows up. So this one is current state to changes captured over time, or historical changes. So in this scenario, our car has changed color from blue to red. And we can see we're capturing the changes in separate files here. So in the first file, we can see that it's yesterday's file, and the car is blue. And then in today's file, the car is red as well. But we may not want to capture it in separate files. We may need to capture it in the same kind of data store. So very, very usefully here, we've got a version number that we can use. You can use sometimes dates as well. So we can see here that we've got the car, it's red, and then in our destination system, we're capturing that it has been red, and it is now red, and it has been blue previously. So we can see for our RealCo requirements that we just need current state to current state. Again, we're a little bit lucky here. We don't need to capture all of the historical data over time. The analytics that we are going to do will work really well with current state to current state. The next thing we want to talk a little bit about is how coupling can show up. So what is coupling? In software engineering, coupling is a degree of dependency between an application's modules or components. Too much coupling can mean that the application is really brittle to change and evolve. It can be difficult to kind of roll out changes. In data engineering, coupling can show up, and it also can impact, but it can show up in some different ways. So here are some examples of kind of different dimensions that I've observed coupling happening in data engineering pipelines. It'd be really interesting to hear maybe later if people have observed the same thing, but I've observed it across a couple of dimensions. So we've got time-based coupling. This is things like I can only run it in a quiet window. I can't run until another process has finished running. Production data store coupling. This is my least favorite form of coupling. This is where we are relying on resources on the production data store when we have to kind of fetch data out of it. So we might have to do things like Bootstrap or replay data from that production data store. We might have to add things into our pipeline where we are throttling data so we don't kind of impact the production data store. Next one is data and schema coupling. This is generally inevitable. We are pulling data out. We are relying on database schemas, and we can be relying on a data distribution, and we can also be kind of dependent on APIs as well. Any kind of system coupling, generally consumers need to know about producers, but if producers need to know about consumers, it can sometimes create some cyclical dependencies, and then any kind of build time or runtime dependencies as well. And as I said, it is inevitable that we have some coupling in our systems, but I think it's really important to understand where they are, so we can kind of, so if we need to do things to kind of guard against them, then we're able to do those things. So I'm not going to talk about coupling in relation to RealCo just yet, because coupling generally is related to the data replication pattern that you choose, and so we'll talk about it in a little minute in context of the data replication patterns. And with that segue, we're going to talk about which data replication pattern to choose. So I'm going to talk about 3, and then we can kind of make a decision at the end about which one is best suited to our RealCo use case. So here are the patterns. So daily snapshot, Bootstrap and Delta, sometimes called snapshot and Delta, snapshot and incremental, backfill and Delta. There's quite a few, and then names for that one, and then an event log. So I'm going to do some data collection because I'm a data engineer. So if you could maybe do a show of hands to say if you've heard of at least one of these patterns before. Awesome, great. Good. So the first one we're going to talk about is the daily snapshot. This is really used a lot, I think, in analytical engines. Really simple. We have a source data store. We are exporting the data in some way. I'm assuming here that we are not kind of doing a query to export the data, and instead we're doing some form of table dump to export it. We are putting it in a CSV bucket, and then we've got an orchestration tool that's coming along and taking that file and storing it somewhere on the file system. So you can see here we've got dated files, and then we've got a data warehouse or a data lake all the way over on the right. And that's kind of either ingesting the data or kind of running queries over the data in the file system. So it's a really kind of common pattern, particularly for analytical use cases. And we can see here, if we were to think about the producer, in this case is team A, so they would be doing like this part of the work. You can imagine that they are taking that data from that source data store and then putting it in that bucket. And over here, we have the consumer, which generally in this case, the consumer would actually be probably a data platform team, and they would have their own kind of set of consumers all the way over to the right. If we wanted to add a new consumer at the same level of this data platform as this data platform consumer, they could just start kind of processing that file from the bucket and do the work to ingest it into their systems. To replay data, so if something has gone wrong, it's just really copying that file again and kind of re-ingesting it. So it's quite straightforward. And where coupling can show up here. So obviously it's a batch process. I'm assuming it's a daily snapshot. It might be an hourly snapshot. It might be a weekly snapshot. So we do have some time-based coupling. So you can see we've got a caster run in a quiet window. Maybe there's some downstream processes that are waiting for the file to appear. And then obviously we've got some database schema and distribution coupling as well. So a really quick summary of the pattern. So yeah, it works for moving data to analytical stores, works for current state to current state and historical over time projections. It's okay for multiple consumers, and not suitable for hybrid or for any use case that requires real-time freshness. And sometimes the SQL can be cumbersome to extract it because the changes, which are what people really care about, are kind of encapsulated in all of the files. So you have to kind of run queries that run over quite a number of files. So I'll pause there. I'd be interested to know who has used a daily snapshot in their, yeah, yeah, pretty common. Cool. The next one we're going to move on to is Bootstrap with Delta. So Bootstrap or snapshot, it can be a variation where the snapshot is really similar to the Bootstrap is really similar to the snapshot that we just saw. So we've got a source system, got a CSV file, it's moving it all the way right to the destination system. And then we've got a delta. So the delta can be either batch or micro batch. So what I'm assuming here is that we've got some trigger that runs at a particular time. It reaches out to an API, it fetches data from the source system, and then it writes it. And it's writing the entire row all the way through the data stream, data writer, and onto the destination system. I want to just emphasize something. I am really oversimplifying. Generally, when I've written these, there's a whole suite of kind of infrastructure that sits around that delta trigger. So sometimes you might have a data store to store where you're up to. You can sometimes put a queue in front of the data reader, so you're kind of reading it in and out. So it is a really oversimplified version of the pattern. In reality, you probably need a little bit more infrastructure to implement. And yeah, and then there's a version of it, Bootstrap and Delta, where we're not actually keeping the two separate. We are just having both the Bootstrap and the Delta go through the same set of pipes. And you can imagine there might be a Bootstrap request that goes all the way over to the source system. So if you look at who's doing what work, we can see that Team A, the producer, are kind of maybe doing all of the work up until the API. And then we have the consumer over here who's doing all of the work to kind of take that data, and it's just a row, and translate it into a data set all the way over there on the right. With this particular pattern, if we want to add new consumers, what might happen is we have a choice, really. We can have each consumer do all of the same amount of work, so we kind of spin up at the data reader and do all of the same amount of work over to the right. Or alternatively, they can kind of share that infrastructure, that data stream. If they are sharing that infrastructure, it can sometimes lead to dependencies between those consumers, because when they do a bootstrap, I'll have to know to ignore that particular bootstrap, that's not for me, and that can kind of lead to churn or spin in the infrastructure, where you've got kind of consumers spinning up going, is this for me? And then it's not, so they don't do anything, which can add a little bit of complexity sometimes. The other one around this one is that for of the patterns that we looked at, the core time projection patterns, it's not so good sometimes for the one for historical changes over time. The reasoning for that is that if you imagine you're just getting the current state of the data store, you just like it's taking the data and it's writing it out. Depending on your frequency of your trigger and the rate of change on that source system, you might actually miss some changes. So if you actually care about getting all of those changes, the delta trigger, you might end up missing some of them. If you have to replay and start again, what happens is that generally when replaying, something has gone wrong with this destination system, we've got to start all over again. Generally when replaying, it's really good to kind of replay into a fresh data set and just start from scratch. But if we're doing that where we had previously captured all of these changes over time, we'll likely be starting from the beginning because the source system just has the current store. We're not storing those historical changes over time there. So there's just some additional kind of complexities with that pattern when we're using it for storing the changes over time. And where coupling can show up. So yeah, quite a few places, again, around the database schema, the API schema, time-based coupling, the delta trigger has to run at intervals throughout the day. We've also got some production data store coupling because we're doing requests via an API, which we're assuming are using resources. It might be very trivial for the delta, but in the scenario for the bootstrap, where we're getting all of the data, that can be quite significant. And yeah, again, we've got a bootstrap replay against the production data store. So here is a really quick summary. Good for replicating real-time data and current state to current state projection, really in that hybrid use case. Good for one or minimal consumers. Doesn't work well for changes over time, data projection, we get the consumer inequality. Replaying and rebootstrapping can be difficult. Multiple consumers leads to churn, and it's really tightly coupled to resources on the production data store. So as a show of hands, who has used that one? I'm going to put my hand up. I've used it quite, yeah. The next one we want to talk about is the event log. So the fundamental concept behind this pattern is that every change to state is encapsulated as an event and then stored in a sequential manner. It's been around for quite a while. It's actually the pattern that is used to replicate databases, to replicate a database and its replica. And it's been a version of this has been a microservices pattern as well. The one I'm showing here is where we are actually streaming the write-ahead log or the transaction log out of the data store. So we're not using any of the kind of the memory or the CPU on the data store. And we're streaming it out as a series of changes. So we've got like create, update, and deletes, which are explicit here. So yeah, we're streaming it out and we're moving it along, and essentially we've kind of shifted the source of truth from that the write-ahead log or the transaction log into the data stream. So adding new consumers to this one is pretty straightforward. Yeah, and replayability is pretty straightforward as well. So to get up to speed with this one, I just start reading the stream right from the beginning, and then I can just kind of keep in sync using that same stream. So to get up to speed is pretty straightforward. What else do I want to say about this? I've got a few things, hold on. Replaying is easy, so if I need to go backwards in time, I can just change my offset and kind of rewind to where I need to start processing again. That might be right to the beginning if something's gone horribly wrong, or it might be just back to a point in time. And it supports both of those kind of core time projections that I spoke about. It supports current state to current state, and it supports the historical over time as well. In reality, not all stream technologies actually have the storage requirements that you can kind of keep that data stream as a source of truth. So kind of you might see some variations here where you're actually writing out to an event store to kind of keep the historical data, and then you have the stream where you're kind of getting real-time up to sync. This might seem like we've gone back to Bootstrap and Delta, and in a way we have a little bit because we've got a data store where we've got a Bootstrap out of, but we've kind of gotten rid of some of the production data store issues, or production data store coupling that we had previously. We no longer have this with this one. To kind of replay, yeah, we don't have to go back to the production data store. And if we look at what work the producer and the consumer might do here, producer might do all of the work here, so they're actually responsible for the data stream, that ordered kind of sequence of events, and then the consumer does over here. And as I said before, replaying the data is quite straightforward here. Adding new consumers is quite straightforward here, and we don't have that consumer inequality where, as the previous pattern, where we can kind of only capture historical changes over time from when we started processing. And yeah, where coupling can show up, obviously with the database schema and data distribution as well. I'm assuming here we're using kind of the write-ahead log, and we don't have any production data store coupling. And pros and cons. So, so we don't have that coupling with the production data store. Same pattern for getting up to speed as with backfill as continuous stream, as long as your infrastructure supports it. Deletes are explicit, works for analytical and hybrid use cases. We have real-time data freshness, decoupled producers and producers. It does require mature data process on the source system, and I haven't really spoken about that. But if you have a scenario where people are allowed to go in and just change values in columns, or add columns, all of that without actually going through like a CI/CD process, all of that will kind of automatically start flowing through your pipeline as well. Who's using Eventlog in some form? Yeah, a little bit less maybe for that one. Yep. All right, so that was a lot of words and a lot of talking for us to kind of pick our pattern. So to help out, I've kind of done a quick summary of the patterns. Looking at things like current state data replication, historical over time, whether it limits production store coupling, how easy it is to replay, real-time freshness. I'll just pause for a second for people to read it. All right, I might do a quick show of hands. Who thinks daily snapshot is a good use case for what we have? Nope. One? Maybe? Yeah. Bootstrap and Delta? Yeah. Eventlog with CDC? Yeah, okay. Yeah. A little bit divided. So I guess we need real-time freshness, and daily snapshot is not really going to give us real-time freshness unless we have some really kind of, I would say, enterprise-grade infrastructure that will help us crunch the data that CSV files. So I'm going to say no to that one. We also, as I said, we don't have a lot of enterprise infrastructure, and I think one of the things with the event log, it's really good to have some kind of enterprise infrastructure. If a team was to go spin up a whole Kafka cluster on their own just to kind of support this one use case, it's a lot of kind of infrastructure work for them to do. So it can kind of be good to have some some enterprise support, I would say. And also with that one as well, we're asking, like if we look at the boundary, Team A, we're doing kind of a lot of the work to own that stream, so maybe there's no room on their backlog for it, which is quite common. So you can see that maybe Bootstrap and Delta is a pattern that would work for us, given our use case, given our context, given what we know about the organization. Move on. And here, we can see our scorecard as well. So our data replication pattern is going to be Bootstrap and Delta. Because of that, we've got quite a little bit of coupling that we're taking through. So we've got the production data store coupling, maybe some time-based coupling as well. And we're just kind of putting that all in the requirements card so we can kind of understand what our solution might need to involve later. The last thing I'm going to talk about in this section is how to solve for idempotency. So generally, idempotency, it means that a function is idempotent. No matter how many times we call it, it still has the same output as if we just called it once. We need to care about it is because generally the systems that we're working with have message delivery guarantees. Usually that message delivery guarantee is at least once, which means that we can get duplicates. So generally, yeah, and what I said earlier as well is that the use case that we use, the core time projection can also impact how we might solve for idempotency as well. So there's a little bit of a dependency, is there? So here's my kind of first principle. When solving for idempotency, don't try to look backwards or forwards in time. What do I mean by that? Sometimes I see this tendency for people to want to look, if you imagine we're processing a stream, and we might want to look to see what's coming next, to see if there's any duplicates next, or to see if there's any duplicates close to us. Or we might want to look backwards in time, and this might be a little bit more controversial, but we might want to look back at what we've already processed. So essentially, we're going to do a read before we write. Why I recommend not using that as a first approach is that it adds complexity to your pipeline, and it makes it harder to reason about it when things go wrong. So I'm a big fan of keeping things as simple as possible. So as I said, generally for solving for idempotency, I look to solve it at the data store level as much as possible, and then taking into consideration what is the core time projection that we care about. So again, we've got this current state core time projection. This is probably the easiest one to solve for idempotency. So we want to do it by uniquely identifying each row, and then using the database or the data store and what it's good for, upserting the data store on that ID. So no matter how many times we process it, it just has the same effect. The next one is current state to changes captured over time. This is a little bit more complex. So if we're lucky and this source system gives us some form of change data capture, like a version ID or a start or end date, we can use that along with the ID or whatever the primary key is and upsert on the data store in that. If it doesn't, we might need to take the ID and take a hash of the columns, the values, and use that hash in the ID to kind of do the upsert to make sure that we're just processing a unique row. And in that scenario, generally ordering will be important. And then I hear you all ask, what if the data store doesn't support upsert? A lot of them don't. I'm thinking of maybe some data warehousing, they might not support an upsert. Generally with that pattern, if you allow duplicates in your role, and then just put a transformation or a view over it that kind of dedupes it for the next stage. That's a solution. Sometimes you might, if you don't have a choice on what data store you're using, sometimes you might have to use a read before you write, but I would really just kind of try and avoid that because, as I said, it adds complexity, it adds costs, and it's kind of like taking up resources. So that is it for RealCo. We can see that we've got use cases hybrid. We know we're going to do current state to current state data projection. We're choosing a Bootstrap and Delta pattern. Or for solving for idempotency, we're going to upsert in the ID. So we can now use this as a guide for what technology choice. We know we need a data store that supports low latency, response times, and we can choose what data stream technology we might want to do. If we're using AWS, we can choose between Kinesis or SQS or whatever that might be. We know we're likely to need infrastructure to keep track of all of the data, the Delta triggers. So we might need another data store and a queue to kind of manage that. And we've got this coupling as well. So we know what our coupling is, and we might need to do things to kind of counteract that. So we might need to ensure that we're only running bootstraps at a particular time of day, so we're not impacting the data store. We might need to look at where we can throttle the pipelines to make sure, again, we're not impacting the data store as well. And maybe we can introduce a read replica, but obviously there's costs and stuff like that. So we can kind of use this to inform what technology choices that we're going to make. But we're also kind of aware of limitations in the choices that we've made right now, and we may have constraints, or we may have some kind of like future technical debt that we need to think about. So the core one here is that we're really lucky that we just need current state to current state for our core time projection. If that was to change and we were need to process historical data over time, we'd have to question whether Bootstrap and Delta was the best choice for that, given kind of some of the issues that it can have when processing that time projection. And then we'd also have to change our upsert on our ID in a data store as well, because it would no longer be adequate, so we'd have to change. So we can kind of see how what seems like a small change can kind of have a big impact on kind of the evolution or the technology decisions that we might need to make. And I guess it's a kind of a common scenario as well for organizations to be in, where it's like, we can do this thing, we have control over our domain, and we can build it ourselves. But I think there needs to be like a little bit of counteracting with understanding how many instances of this is happening in the organization, how much duplication is, and ensuring we have kind of those enterprise infrastructure conversations at the right time. So that is it for this part. How much time? I've got 3 minutes. I'm going to quickly, I'll probably run out of time for questions, but I just want to quickly talk about what it means to shift to a data product. So obviously data mesh is a really hot topic at the moment. And I think up to now, when we're thinking about building data pipelines, we kind of think of the architectural quantum, or like the smallest kind of deployable thing, as those replication patterns, or those pipelines that I've just spoken about. But we can see here that a data product is a little bit more than that. So I've got a definition here by David Coles, who's down there. Thanks, Dave. So it's a data set plus producer autonomy, validated consumer value, and affordances for decentralized governance. So you can, if we look at the architecture here, we can see we've got polyglot output data ports, we've got input data ports, we've got control ports, self-serve descriptions, we've got logs, we've got metrics, and within there we've got a domain and data products. So if we just look where what we just spoke about might fit in. So we imagine that we've got internally within a data product, and we might be building like a pipeline or using a replication pattern to get that data out there. But the context of what the smallest deployable thing has expanded. It might be that we need to supply multiple output data ports. The ones we spoke about now, I'm really on a countdown. The ones we spoke about now are called generally called source-aligned data products, because we are moving it from the source system outwards. There is a lot of debate about whether or not they should actually be made available outside of the domain. So we'd probably have to kind of shift our use case a little bit and imagine that the boat features were likely being made by boat teams. But we could see that Eventlog, it's got a data set that we could kind of, you could see that kind of fitting in as a replication pattern within a data product, as well as daily snapshot to kind of meet the different user needs. Cool. All right, so that's a quick summary. So we use RealCo, we picked some data replication pattern, we chose a data replication pattern for them, we had the scorecard, we stepped through kind of some really key things that we need to understand, and then made some technology choices, but also understand kind of the constraints at which we are working. So I am out of time for questions. I can see that, but I'll be down at the ThoughtWorks booth. If you have any questions, please come chat to me. I'm happy to answer any that you may have. So thank you.